current balance. Purpose of the current balance is to determine the flux density. In the design of the current balance, there will be a rider with a weight W, and its moment about knife edge will be the weight W multiplied by the distance x. And that will give rise to the expression mgx, where m is the mass of the rider. On the other hand, to keep this coil in balance, a magnetic force will be generated downwards. To do so, you have a battery that will pass a current through the coil. So in this example, the direction of the current is in this direction, which is perpendicular to the magnetic field B, which is acting in this direction. And using your Fleming's left-hand rule, you could determine that the force acting on the coil PQ is directed downwards, and its moment about the knife edge will be F multiplied by D, which is the expression here. And given that F is equal to BIL, we could then be able to calculate the magnetic flux density as indicated in this expression. In this example, it is important to note that the direction of the current flow in this portion of the coil does not give rise to any magnetic force, since the direction of the current flow is the same as that of the magnetic field. And the current flow in this portion of the coil doesn't give rise to a magnetic force, since there is no magnetic flux density there. With that, let's take a look at some examples. In this example that we have the weight of the rider as WR, so its moment about the knife edge is WR multiplied by L2, which is given here. And the current flow on the other end of the coil will give rise to a magnetic force which is downwards, and its moment will be FB times L1. And if L1 is equal to L2, then your magnetic force FB is equal to WR. It's important to note that the center of gravity of the coil coincides with the pivot. And therefore, in this example, the weight of the coil does not give rise to any moment about the knife edge. However, in this example, the weight of the coil no longer coincides with the pivot. And hence, you will now see that the weight of the coil will create now an additional moment, which is WC multiplied by your X. And this moment must be added to the moment caused by the weight of the rider, which will then be equal to the magnetic force multiplied by L1. In the next situation, the weight of the coil will now be on the opposite end of the weight of the rider. You will find that it's the same direction as the moment caused by the magnetic force, which when added together will be equal to the weight of the rider multiplied by L2. Finally, you could also have the case whereby the current now changes its direction. Because of that, the magnetic force is now acting upwards. Hence, the moment caused by the magnetic force is in the same direction as the moment caused by the weight of the rider, which is clockwise, and hence you aggregate them together, and that is equal to the opposing moment that is caused by the weight of the coil.